Guys, welcome back. A very warm welcome to my another video on my YouTube channel, which is Classes by Invesharas. And the next topic of my video is properties of determinants. So let's discuss the first property of determinant. Okay, the first property is the value of a determinant does not change when rows are changed into corresponding columns. So let's move towards its proof. Let's delta is equal to a1 a2 a3 b1 b2 b3 and c1 c2 c3. Okay, now and again delta dash b1 a1 b1 c1 a2 b2 c2 and a3 b3 c3. Then we have to prove that delta dash is equal to delta. Sorry, there are so many mosquitoes in my house, so I'm got very disturbed. Sorry for that. Sorry for the inconvenience. Let's move. Delta dash is equal to, sorry, it's delta only. Delta is a1 a2 a3 b1 b2 b3 c1 c2 c3. Now a1 is a1 b2 c3 b2 c3 and b3 c2. Okay, now b1 is a2 c3 and a3 c2 plus c1 is equal to c1 a2 b3 and a3 b2. We can take it as equation number 1. Now delta dash a1 b1 c1 a2 b2 c2 and a3 b3 c3 equal to a1 b1 c b1 b2 c3 minus b3 c2 minus a2 b1 b1 c3 minus b3 c1 plus a3 b1 c2 minus b2 c1. a1 b2 c3 minus b3 c2 minus a2 b1 c it's c2 b3 a2 b3 c1 a2 b1 c2 minus a3 b2 c1. Next step is a1 b2 c3 minus b3 c2 b1 a2 c3 minus a3 c2 plus c b1 c2 b1 is a2 b3 minus a3 b2. Equation third. Sorry, it's equation second. Now from equation first and equation second, delta dash is equal to delta. Now let's move towards an example. Delta 1 2 0 2 3 1 and 3 4 5 1 15 minus 4 minus 2 10 minus 0 plus 3 2 minus 0 is equal to minus 3. And delta dash 1 2 3 2 3 4 and 0 1 5 1 15 minus 4. Now 2 10 minus 3 plus 0 8 minus 9 and minus 3. So delta dash is equal to delta. So this is the first property. Now let's move towards the second property. The second property is if any two rows or columns of a determinant are interchanged, the sign of a determinant is changed, but its value remains the same. Let delta is equal to a1 a2 a3 b1 b2 b3 c1 c2 c3 and delta dash is equal to a3 a2 a1 b3 b2 b1 and a3 a2 a1. Means a3 a2 a1 is again repeated a3 a2 a1. Now then we have to prove that delta dash is equal to minus delta. Now expanding the determinant along row, angle a1 delta a1 b2 c3 minus b3 c2 minus b1 a2 c3 minus a3 c2 plus c1 a2 b3 minus a3 b2. Equation 1. Now delta dash a3 a2 a1 b3 b2 b1 and c3 c2 c1. Now r1 arrow r3 delta dash a3 b2 c1 minus b1 c2 minus b3 a2 c1 minus a1 c2 plus a3 it's c3 A2 B1 minus B1 B2. A3 B2 C1 minus A3 B1 C2 minus B3 A2 C1 plus A1 B3 C2 plus C3 A2 B1 minus A1 B2 C3. Now A1 B2 C3 minus B3 C2 plus B1 A2 C3 minus A3 C2. C1 A2 B3 minus A3 B2. Equation 2. From equation 1, first and second delta dash and minus delta are same. Now let's move toward the third property, which is the value of a determinant is 0 if any two rows and columns are identical. So let's move towards the proof. Proof is let delta A1 A2 A1 B1 B2 B1 C2 C1 C2 C1. Then we have to prove that delta is equal to 0. Then delta is equal to A1 A2 A1 B1 B2 B1 C1 C2 C1. Now minus A1 A2 A1 B1 B2 B1 and C1 C2 C1. Delta R1 both side arrow R3. Thus delta is equal to minus delta. 2 delta is equal to 0. That means delta is equal to 0. So let's move towards example. Delta is equal to 1 2 1 2 3 2 and 3 4 3. 1 9 minus 8 minus 2 6 minus 4 plus 3 4 minus 3. 1 plus 1 minus 4 plus 3 is equal to 0. Now let's move towards fourth property, which is if any constituent in any row or in any column is multiplied by the same factor, then the determinant is multiplied by that factor. If each constituent in any row or any column multiplied by that factor. In other words, if a factor is common in any row or column, then that common factor can be taken out as a product of the determinant. So that's all for today. Thank you so much. Please like, subscribe and share my channel. And I am